Hello my friend, welcome to the KJM Smart YouTube channel. Today I am discussing the balancing of redox reactions, which are very important questions in the point of view of your competitive exams or even if you are appearing for the board exams. So these questions actually have a trick or the steps which by following these things you will be able to solve every type of questions, and I guarantee you that you will be able to solve questions on your own by the end of this video. So let's start the video. So whenever you got this type of question, you have to see first that on which medium or in which medium this reaction is going on. So first of all you will see which reagent is given. So I have very easily classified these reagents that when you have the H plus and H2O, this will be a acidic medium. But when you have OH minus and H2O, this will be a basic medium. And this is no confusion, there is no confusion in between these two, and you will be easily distinguish between them. So whenever you have this type of reagents, you will be understanding that in this specific medium this reaction is going on. After that, you have to look for the individual oxidation number. For these redox reactions, you must know the oxidation number of elements. So some of the examples I have given here. So as you can see, these are the oxidations number you must know. For example, oxygen have -2 as its oxidation number, hydrogen have +1, potassium have +1, or sodium have +1. So chlorine have -1 or aluminium have +3. So these are some of the oxidation number which are used more, but there are also many other elements also. So you have to recall those oxidation numbers from your books. And commonly these oxidation numbers are the valencies of an atom, what we call, but still some of the changes are also found. So you have to be knowing that. And oxidation number of a neutral atom will be always 0. For example, if you have a chlorine like this Cl2 and there is no charge, as you can see, so in that time the oxidation number will be 0. Or also, for example, H2, there is no charge on it, that's why the oxidation number will be 0. But if charge is present, let's say if I had a charge minus here, then the chlorine will not have 0 but -1 as the charge. Okay, so but if the charge is present, then it is taken into account. So you got to know that how to get to know that oxidation number of a neutral atom or a single atom. But now let's see how to calculate the oxidation number when a compound is given. For example, here MnO4 minus. So you are seeing that minus is the charge, net charge of whole compound. But you know that oxygen have -2 as the oxidation number, but I don't know what is the oxidation number of manganese, so I have to calculate it. So how to calculate it? First let's know. So first you have to take the oxidation number of Mn as X. Let's take it. And we know that the oxidation number of oxygen is -2 and there is 4 of it. That's why I will do this thing, -2 into 4. And you know that the whole compound has the net charge as -1. That's why I will equate this to -1. Now from this I can calculate X, that X will be equal to -2 4s are 8, -8. When -8 goes here, it will be +8. So -1 plus 8 will be equal to 7. So here in this case, manganese has +7 as its oxidation state, oxidation number. By this method, or this is how you can calculate the oxidation number of individual atoms when there is a compound given. So this is very important because the same thing is followed in the original question. For example, here MnO4 minus is there. So first of all you have to do the thing is how much oxidation number do this Mn have. So by that we got to know that it have +7. The same follows here. So there is 4 oxygen, so -8. When -8 goes to -2, that will be +8. So -2 plus 8 will be +6. So in this case, carbon, that is carbon so C2 will have plus 6. So if you have C2 as plus 6, then there is two of them. That's why one single carbon will have plus 3 as oxidation number. So I will write plus 3 on this. Then only the total charge will be neutral or 0 of this compound. So let's come to here. So when they have given individual atom like this and they have also given the charge, then there is no problem that directly you have the oxidation number. Here in this case CO2. So you know that oxygen have -2. So -2 is there. I don't know the value of carbon. So I will write X, and that will be equal to, since 2 oxygen is there here, I have to multiply it to 2, and that will be equal to 0 as we don't have any charge on this compound. So after that we have to just simply calculate the X. X is equal to, when -4 goes there, I will have plus 4. So carbon will have in this case plus 4 as the oxidation number. So this is the first initial step, that you have to calculate the oxidation number of each and every atom which is present or which you can see in the question. After this step, understand the correct method that you have to go for the change happened during the reaction. For example, so Mn2, here as you can see, Mn2 here Mn, how much change happened in this case? So as you can see here, the 7 was its oxidation number, and in this case it is 2. So what you will do is, you have to calculate final minus initial, that is 2 minus 7, but you have to take only the magnitude of it, so that will be equal to 5. Or you can simply say that the change is 5 as you can see. Now the same applies for here also, that carbon when it goes from here to here, how much change happened? So here it was 3 and here it is 4. So the difference between them is 1. But in this case what happens is, there is not only one carbon but 2 carbons in this case. That's why multiply it by 2. Okay, and you have to check the number of carbons or number of manganese only in the reactant side, not in the product side. Your whole concentration must be towards the reactant in this whole case. Okay, after this step you just have to do one thing, is cross multiplication. So this thing you have to multiply to this one, and this 5 you have to multiply to this one. So you understand this, that here we are doing cross multiplication compounds. So what I will do is, I will do the cross multiplication. As you can see now, I will multiply 2 to this compound MnO4 minus, and the 5 to this compound C2O4 2 minus, and the pretty much reaction will be remaining as it is. As you can see, everything will be remaining as it is. So this was the second step. Okay, after this what you have to do is, now you have to balance all the other atoms, except, means all atoms which are you seeing, but except oxygen or hydrogen. Here in this case there is no hydrogen present, so I don't have to check it. But oxygen, there is oxygen, but I don't have to check balancing of oxygen right now. I just have to check how much other atoms are there here and whether it is balanced here or not. So as you can see here, there are 2 manganese compound, or what is that, atom. So I will write 2 here so that both the side it will match. Here I have total of 10 carbon. As you can see, C2 is there and 5 is there. 10 carbons are there, but here in this case I have only 1 carbon, so I will write 10 in this case. So I actually balanced the other atoms except oxygen and hydrogen. I balanced every other atoms. Now this was the third step. So first step to find is the difference, and multiply is the second step. Now the third step is, you just have to balance the atoms other than oxygen or hydrogen. Now you got to know how to balance the atoms except the oxygen or hydrogen. So now the thing came to the balancing of oxygen. How to balance the oxygen? So you can see here that you have to first check that how much oxygens are there on left hand side and right hand side, and then you can balance the oxygen. So as you can see in the left hand side, you have 4 oxygen here but 2 molecules, that's why there is total of 8 oxygen in this case. And here there is 4 oxygen but 5 molecules, that's why 20 oxygen in this case. Now let's see here. So here you have 10 CO2 means 10 into 2, 20 oxygen in this case. So here there are total of 28 oxygen but here only 20. Now you got to know that you have to add something to balance 8 oxygen on the right hand side. So for that I will simply add the water molecules so that the oxygen will be balanced. How much water molecule I will add? So since there are 8 oxygen less, so I will add 8 water molecules. But you also have to know that while adding water molecule, you also added the number of hydrogens, total of 16 hydrogens. So that you also have to balance this hydrogen. That's why I will add 16 hydrogens on the left hand side. By that you now can see that both the hydrogens and oxygen are balanced on both the side. So let's see, the reaction becomes like this. So as you can see in this reaction, total of 16 hydrogens added here and 8 H2 added on the right side. So now actually the reaction came to an end, the balancing actually came to an end, but there is a checkpoint. So whether you have done it right or wrong, for to check that you have to calculate the charges on both the side. So how to calculate that? Let's see. So 16 H plus is there, it means total of 16 plus H plus, let's see, H plus only I will write. Here there is 2 electrons in this case, and here 5 2 minus, the whole 2 minus is for whole compound. There are 5 compounds like that, that's why 5 into 2, that is 10 electrons in this case. So 16 H plus is there, total of 12 electrons is there, means there is plus charge more. So 16 minus 12 is 4. So there are total of 4 plus charge in this case. But when you see here it is 4 because 2 of Mn2 plus means 4 plus charge. When you come to see CO2 is a neutral molecule, as you know, there is no charge on it, that's why it is 0. Also same for water is also a neutral atom, there is no charge, that's why this is also 0. So now you got to know that both sides there is a 4 plus and 4 plus. You are done with this. You can pause this video and do this, and after that you can check it. So I will do it like this. As I said, first you have to see for the oxidation number. Here they have given 2 plus, so that's why there is no problem. But here Cr2 I have to calculate. Since I have total of 7 oxygen in this case and the total charge is -2, so 7 means the oxygen have -2 as its charge, so that's why -2 into 7 is -14. When it goes there, it will be like this thing. I will calculate for you for if you don't getting it. So 2x, because there are total of 2 chromium, and after that chromium it is, and after that plus 7 into the charge. As I said, the oxidation number of oxygen is -2, so I will write that, but the whole charge, the whole compound have the charge as -2. So when you calculate for x, you will get something like this. This -14 will go there, becomes +14, and it will become 14 minus 2, that is 12. Okay, so after that you get x as 6, because 12 by 2 is 6. So you got to know that 6 is the oxidation number of Cr2. After that I will go here they have given Fe3 plus already, and Cr3 plus is also already given. I don't have to do again. Now seeing, as I said, you have to cross multiply, but before that you have to check the difference between them. From Fe, from reactant to product, how much change has happened? As you can see, there is 2 plus here and here 3 plus, so there is change of 1. But here, as you can check, Cr2, when it goes from reactant to product, the plus 6 to here it is converted into 3 plus. So there are total of 3 change is 3, the electron change. Now you have to multiply 2, because you, as I said, your whole concentration must be towards the reactant side, not on the product side, while seeing these things. So you have total 2 chromium, so that's why you have to multiply 2 in this case. So that will give you 6 as the number. And the third step was to multiply and cross multiply the numbers you got by difference. So when I cross multiply it, I will get something like this. So 6Fe2 plus, and then I have only one change here, so Cr2 O72 minus. At least you have to write or keep on writing the total charge of the compound, okay? That will give you Fe3 plus and plus Cr3 plus. Now, as the step goes forward, I said you that you have to balance every other atom except the oxygen or hydrogen if present. So if there is like this 6 Fe here, so as you can see here there is only one, so I will write 6 also here. Now here you have total of 2 chromium, but here only one chromium is present, so I will write 2 here. So you got to know that every other atoms now balanced. When this step is over, now you have to balance the oxygen. So remember this every time, okay? Since it is acidic medium itself, H plus and H2O is only there, you have to follow the same steps as I previously said. Now you have to see how much oxygen is there. So as you can see here there are total of 7 oxygen, but here there is no oxygen at all. Oxygen is 0 in this case. So that's why you have to add 7 water molecules in this case, plus 7 water molecules. The final reaction seems something like this. Not final, but when you balance the oxygen, you will see something like this. So 6 Fe3 plus 2 Cr3 plus. Now as I added the 7 H2O in this case, as already I have said that you also added hydrogen molecules along with the water. That's why you have to add number of hydrogens on the left hand side also to balance it. How much hydrogens you have added? 14. That's why I will add 14 H plus on the left hand side. Now as you can see, as I added 14 H plus here and also the hydrogen here, both hydrogen and oxygen is balanced. As I said, now the time you add H plus, actually the whole reaction is now balanced. But for the checkpoint, you can check that how much charges are there. Here I have 14 plus and here I have total 6 into 2, 12 plus. And here the net charge is 2 minus. So total is 14 plus 12 is 26. 26 minus 2 is 24 plus charge is there on the left hand side. Let's calculate that in the right hand side. So you have total of 6 into 3, that is 18 plus in this case. Here 2 into 3, 6 plus in this case. And you know that the water is neutral, so 0. When you add 18 plus 6, you will again get 24 plus. So as I said, this is just a checkpoint that it indicates that you actually done the balancing exactly correct. And if you done wrongly, then the number of electrons or the charges on the both the side will not be equal, and you can recheck where you have made mistake. So this is how you completely do the whole reaction in just minutes. But you have to know that I here expanded this much just to explain you. So now you can check that where you have gone wrong and can correct that mistake. So I am now turning to the basic medium. I will not waste much time of you. Please watch the complete video. This will be very much helpful, and for the next time you will not be mistaken in your exams or even competitive exams. This will be very helpful. Okay, let's go for basic medium now. So as you can see, the steps are similar. First you have to check for the oxidation number for first. So as you can see, the Cl2 is a neutral atom, so I will write 0 as its oxidation number. But IO3 I have to calculate, such as like, since one iodine is there, X plus, there are 3 oxygens, so 3 into minus 2, and the net charge is minus 1, that's why I will write minus 1. So X will be equal to, so 6, here minus 1 is there, so minus 6 when it goes there, plus 6 happens, so 6 minus 1 is 5, that's why X will come as 5, so iodine has the oxidation number as 5. And here they have given it as a charge, negative charge, you have to take that account. And here you also have to calculate again that X plus, there are total of 4 oxygen, so 4 into minus 2, net charge is minus 1, so minus 8 when it goes there, plus 8, so X will be plus 7. So iodine here in this case have plus 7 as oxidation number. Now let's see what is the change. So Cl2 when it goes here to here, there is a change of 1 electron, and you have to take only the magnitude, so 1 electron, but there are total of 2 Cl2 in this case, means chlorine are 2 in number, and you have to check for only reactant. That's why 1 into 2, that is 2 in this case. When it goes from iodine here to here, there are totally of 5 to 7. That's why only 2 changes here in this case, but only 1 iodine is there, so I have to multiply only 1 in this case. So as you can see, here also 2, here also 2. I will cross multiply both the side 2, and the reaction seems like this: 2Cl2, where it has 0 as its oxidation state, and again 2 is also multiplied to here, and minus is the whole charge. Since it is a basic medium, I have written OH minus and H2O, and Cl minus and IO4 minus is remaining as it is. Now I said that after cross multiplying it, you have to balance the reaction, but only the atoms other than oxygen or hydrogen. So oxygen is there, but I don't have to check it now. I have to check for others. So Cl2 is there, but here total of 4 chlorine is there. 2 into 2, 4. But here there is only 1 chlorine. That's why I will write 4 in this case. Here iodine is 2 in number. So but here only 1. So I will write 2. So every other atom is now balanced. Now you have to check, after balancing every other atoms, you have to check for oxygen now. You have total of 6 oxygen, as you can see. So 6 oxygen in the left hand side. But here, as you can see, there are total of 8 oxygen. But guys, if you do this oxygen method in the basic medium, whenever there is a basic medium, if you do this thing, then you will be wrong. Okay, my friend, let me say why you will be wrong if you do this balancing of oxygen before balancing the charge itself. Note this point, my friend, in your notes, that whenever there is a basic medium, before balancing the oxygen itself, you have to balance the charges on both the side. So let me balance it. So here 2 into 0, so it is actually a neutral molecule, so 0. Here there will be 2 minus, isn't it? Because there are minus of the net charge and 2 of them. And here, as you can see, there are total of 4 minus, and IO4 minus, the net charge is minus, again 2 minus. So when you compare both the side, this one is 0. So minus 2 is there, here minus 6 is there. So you got to see here that there are total of 4 electron difference both the side. If you see, 4 electron difference is there. So for that you have to add the 4 to this side, then only both the side there will be matching. If you add 4 electrons by adding OH minus, means how you will balance it? Adding 4 OH minus will fetch you the 4 electron, and that will make 4 negative charge on the left hand side, and both the side where there will be minus 6, and that is the balancing what I was telling you. Now let's see what happens when I add it. So I will add 4 OH minus here as said. So 2Cl2 is there, plus 2 IO3 minus is there. Since it is a basic medium, I am doing it. Now here it is 4Cl minus and 2 IO4 minus. In this case 4 OH minus is there, that's why I also added the hydrogen in this case. So to balance that hydrogen on the right hand side, I will have to add 2 water molecules. Then only 4 hydrogen comes along with 2 water molecules. That's why I will add 2 water molecules here. Now by the time you add this 2 water molecule, actually the number of charges or whatever the hydrogen is there, that is balanced. Because as you can see, this whole step is now ended, the balancing has ended. But for a checkpoint, if you want to check that if you have done it correct or not, you can check the number of hydrogens both the side. So here you have 4 hydrogens, and here also you have 4 hydrogens. If you calculate oxygen is also here 4 oxygen. Here there is total of 3 to the 6, 10 oxygens are there here. And if you calculate here, 2 4 is 8, 8 and 2, again here also 10 oxygens are there. So for this, your balancing of redox reaction in the basic medium has also ended. Oh, okay my friends, that was the thing which I wanted to tell in this video. So that was all about the redox reactions in basic medium and acidic medium. There are still much more reactions like disproportionation reaction or half cell reactions. I will complete that in the upcoming video. So for that, please follow that channel or subscribe that button. Now the thing is, you have to practice whatever I have given today, and again watch the video, rewatch it, and solve the questions without seeing it. Then only you can get your confidence that you are able to solve every questions without seeing and even without mistake. Yes, mistakes are common. Do it, but again practice it, so you will definitely clear everything. These are very much simpler and easier. You will get it. Okay, Bye.